This comes from the Mathematical Methods 2018 Tech Allowed SAC question 4, which investigates hyperbolas in this form. So what do I know about that form? Well, I know that from looking at the denominator, my vertical asymptote will be at x equals minus d on c. And if I use prop frac to put it into a proper fraction, and then I just consider the fraction part to combine them, then I know that it also equals AD plus BC on C, and down the bottom here we have CX plus D plus A on C, and it's a minus maybe at the front. So therefore I have my other asymptote, which is my horizontal asymptote, which is y equals A on C. So to the first question, if B and C were 1, so I've got C equals minus D as being one asymptote, and y equals A as being the other asymptote. Describe the asymptotes in terms of A and D if C is 1 and B varies. Well, if C is 1 and C is 1, it's the same answer. X equals minus D and Y equals A, because the asymptotes have nothing to do with B. B is this number here, and that's not going to affect the asymptote. The asymptote is affected by C and D and by A and C. Consider the value when C varies where the asymptote shares the same constant. State the condition required for the vertical and horizontal asymptotes to have the same constant. Well, if they have to have the same constant, and I've got x equals minus d on c and a on c, therefore, to have the same constant, a has to equal minus d. Doesn't matter what c equals, because c is the denominator of both of them, so that's the condition for them to have the same constant. When the vertical and horizontal have the same constant, express the value of the constant in terms of A, B, C, and D. So the only way that they will have the same constant is if A equals minus D. So that if you've got 3x plus 1 on top of 2x, then this has to be minus 3. It has to be minus 3 because this has to equal the negative of that. So the constant will either be minus d on c, or you could write a on c, but a has to equal minus d. If a equals minus d, then either of these will be a correct answer to this particular question.